All right, you guys, I am on that one tiny little section in 7.1 that we skipped. There were 4 practice problems, just identifying some important vocab words that you have written in your reading guide. And I just want you to kind of go through. What I would say is go ahead and pause the video and try and identify these. This is what I would have you do, like in groups. And I'd be like, okay, guys, work with your peeps around you. So pause the video, fill these out, and then I'll go through them one at a time. First of all, we've got Arizona iced tea. Not if I have any tea drinkers in the class, but every time you fill a bottle, it's supposed to have an average of 20 ounces in it, right? But there's like error with the machinery that fills the bottles full of the tea, all that kind of stuff. So quality control inspectors sample 50 bottles, and it turns out that the average of just those 50 are 19.6. Okay, so what I'm going to do is I'm going to identify the population is all the bottles at this plant. Okay, the parameter, the population and the parameter go together. Do you guys remember that from the reading guide? Think of the P's, and then the sample and the statistic go together. Think of the S's. So the parameter is what we are assuming to be true, what we are told about the entire average of all of the population of the bottles. Okay, that's the 20 ounces. Here's the symbol that goes with it. The sample we took is 50 bottles. And the statistic based on those 50 bottles is 19.6. Notice that is an X bar, okay? The mu goes with the entire population, which is the parameter. The X bar goes with just the sample, which is the statistic. All right, number 2, a New York to Denver flight, 8% of the 125 passengers are selected for random security screening. 8%, this is a proportion, not a number of ounces. See the difference? So we're not going to be using mu's and x's for this problem. We're going to be using p's. This is a percentage. We're going to express it as a proportion. P would be 8%. And according to TSA, 10% of the passengers are randomly chosen. Let's talk about sample, statistic, parameter, population. The population is everyone at this airport. Okay, we are on a we're talking New York to Denver specific flight, but TSA claims something about everyone at the airport. That's the population. And they claim that 10% of the population at the airport are selected. That is a P. The sample is the passengers selected just from this flight. That's who we're like looking at to gather our data. And the statistic is the 8%. That is a P hat. Do you remember that symbol? You should have it in your reading guide. It's exactly the same as the mu versus the X bar. The P goes with the population. The P hat is just one sample. And you guys just keep in mind that if we took a different sample of 50 bottles, do you think it would be 19.6? Probably not. It'd be something different. If we took a different sample of passengers, maybe from a different flight, do you think it would be 8%? Maybe not. It might be 9 or 11, right? Every time we take one of these samples, we get a different number. We have a Gallup poll asking 515 randomly selected adults, this is our sample, if they believe in ghosts. Of the respondents, 160 of them said yes, okay? The population is all U.S. adults. That is our population of interest where the sample was taken from. The parameter, we're not told actually how many people we think believe in ghosts. So we actually don't know the P, interesting. The sample is the 515 people that were selected, and the statistic is 160 out of 515 of them. You can crunch that number into a decimal fraction percent, doesn't matter. That is going to be our P hat. It's a certain fraction in this case, but it's a number of people out of 515. Last one, during the winter months, the temperatures outside of a cabin can stay well below freezing. So we set the thermostat at 50 degrees to make sure nothing freezes in the house when we're gone. She wants to know how low the temperature actually gets. So she has this special digital thermometer, and it records the indoor temperature at 10 randomly chosen times. And the minimum reading, keyword there, they're not averaging the 10 together, they're asking for the minimum, is 40 degrees. So let's see what this one looks like. The population is all the temperature readings on that day. There's like a bajillion of them, right? It's a continuous variable. Time is. The parameter is 50, the mu. That's what they set the thermostat at. The sample is the 10 randomly chosen times. The statistic is the 40 degrees. It's actually an X value representing the minimum. We don't have like a symbol for minimum, but it's definitely not an X bar, okay? Do you remember the example we did in class yesterday with the cards and I was having you calculate medians? and it was kind of freaking some of us out because we thought we were always supposed to do like means. In this case, we're doing a minimum. Here's just another example where it's not always a mean that we're analyzing, but that's okay. All right. Now, we already did this in class yesterday. Your little tiny reading guide should be filled out with some formulas that have a bunch of P's on them. See the P's here and here and here. Check that for me. Here, there's P's everywhere. Because the title of this, section is sample proportions, okay? I'm going to skip this exercise and go down to this thing called Candy Machine. Okay, this is kind of cool. If you actually click on this link, you can do this too, and you might get different results. But imagine that we have this giant candy machine like at the door of a restaurant where you put a quarter in and you spin the wheel, you know what I'm talking about? And let's say that it's full of Reese's Pieces, which is not the best candy like OG M&Ms are, but whatever. And when you put money in, you spin the wheel or the little crank or whatever, and the candies fall out, okay? And so step 1 says the proportion of oranges in this entire machine, P, is 45. So I actually have this open, and I'm going to change the proportion to 45. It's set on 50, but whatever, because the question says 45. What that means is 45% of the candies in this machine are oranges, okay? Proportions, guys. We're on this section called proportions. What else am I supposed to do? Sorry for flipping back and forth. Watch as 25 candies are dispensed. Okay, I wonder when I put my quarter in if I'm going to get exactly 45% oranges out. What do you think? It might be close to 45, but it's probably not going to be exactly 45, right? This is the idea of the sampling distribution. We're not always going to get a sample with exactly 45% orange Reese's Pieces in it. But let's see what happens. So 25 candies, number of samples, show animation, because this is kind of fun. I want the proportion of orange checked, so I'm going to check that under statistic. And I want it to give me the summary statistics, so I'm going to check that. And I think I'm ready to go. So watch this. If you have the animation thing checked, if you hit draw samples, it spins it and it separates them, and it's like super fun and like mesmerizing to watch. And wow, you guys, 64% of the Reese's Pieces were orange. And do you see how there's a dot on the dot plot down here also by 64%? Okay, so we got 64% my very first spin. Maybe if you did it, you got something different, but I got, whoops, I'm going to write down my p hat was 0.64. Okay, you might have gotten a different one, and that's fine, doesn't matter. Now it says draw 9 more samples. What do you think if I do this 9 more times? So we have a total of 10. Let's see what happens. I'm going to do 9 more times. So see where it says number of samples? I'm going to change that to 9. And I'm going to keep the one dot that's already there at 64%. Okay, I'm going to hit draw samples, and I still have show animation checked. So watch. And we're going to play the Jeopardy music for a second. Do, 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 do. By the way, if you unclick show animation, it goes a lot faster, but it's just really fun to pretend like you're sitting in a restaurant waiting for Reese's Pieces to come out of this machine, okay? I think we're on 5. This is 6 maybe. I lost count. It's okay. We're almost done. Are you having fun yet? Once it has all 9 of my other samples, it's going to put all the dots on the dot plot. It's going to average all those dots together. Oh, wow. Okay, so it looks like the smallest proportion of oranges we got on one of those cranks was 24%. I got a couple 60-somethings, okay? And remember, this is like what we did with the cards yesterday in class. You know how it's really hard to tell when you like don't do something that often, but if you do it like 500 times, then it's easier to tell what the shape of the distribution is. So right now, if you look at my dot plot down there with the 10 dots on it, I don't really know what the shape is. There's like not enough to tell, right? But do you see where it says mean? When I average all of those sample proportions together, I get really close to 45. Isn't that kind of cool? And I got a standard deviation there also. So what questions do they want me to answer here? Draw 9 more samples. What was the mean of our 10 sample proportions? So the mean of the p hats, see what I'm doing there? The mean of the p hats, look at those symbols. It was 0.452, if I remember correctly. And the standard deviation of all the p-hats was, what was that number? Sorry for flipping back and forth, 0.133. And I bet your dot plot, if you clicked on this link and did what I did, might look a little bit different. Number 4 says, let's study a sample, or 400 samples. Okay, great. So I have 10 there already. I'm going to have it do 390 more. But I'm going to uncheck show animation because we don't have time to sit here for 390 cranks. And now I'm going to say draw samples, and let's see what happens. Wow, look how fast it did that. Look what my mean is. The mean is 45, the standard deviation is 0.104. And look how beautifully, like, normally approximated it looks. And keep in mind, this is only 400 samples. Based on all the candies in there with a sample size of 25, I bet there's like a bajillion different ways to sample 25 candies with a quarter, okay? But the mean is 45, and my standard deviation is 0.104. Okay, so the shape was approximately normal. It was symmetric and bell-shaped, right? The center, the mean of all the p-hats now was 0.450, if I remember correctly. The spread, okay, so the sigma of all the p-hats, what was it, 0.1, I think, if I remember correctly, 0.104. And outliers, there were not any that were obvious, okay? Yeah, we have some minimums and some maximums, but nothing fell like way far away from all the rest, okay? So that is kind of cool, kind of what we did in class yesterday with the cards, but with a fun little candy machine. What if we dispensed 50 candies at a time instead of 25? 50 instead of 25. Okay, so increase your sample size, decrease your what? Spread. Let's see what 400 samples of 50 looks like, and let's compare. We're going to describe the dot plot. So I'm going to clear this. How do I clear this? Reset way at the bottom. Okay, great. I'm going to do samples of 50 this time. And I'm going to do 400 times, just like we did on the last one, except I'm going to do it all at once. So all I did is I kept the proportion of oranges as 0.45, but I changed the number of candies you get when you put in a quarter to 50 instead of 25. I'm not going to show animation. I want the summary statistics. Let's draw samples. Wowza. Okay, look at the mean and look at the standard deviation. Wow, it got smaller. Hey. That's interesting, and that's because when you take a bigger sample, you're less likely to get something extremely far away from the 45%. Okay, so what was the mean? 45 and 0.072. That's interesting. The spread was 0.072. Notice how that got smaller. In fact, I'm going to make a note about that because that is important. Look, the spread went down, and I'm going to say increase n, decrease sigma. Wow, that is a beautiful representation. The shape was still approximately normal, and the outliers were still not existent, okay? How would the sampling distribution of p-hat change if the proportion of oranges was 0.15? What if there were only 15% oranges in the machine instead of 45? Okay, I'm pretty sure, I mean, you can play around with that if you want, but wouldn't that just make the center 0.15 instead of 0.45 when we took samples over and over and over and over and over again? Does our answer depend on whether n equals n or n equals 50? N equals 25 or n equals 50? Not really. But you know what happens when n equals 50. We have a smaller standard deviation. We saw that right here, and you can play around with that machine also. That's just a very brief introduction, again, to proportions. What I want you to understand about this question is that we were analyzing a p. It represents a percentage or a proportion of orange candies. It wasn't a whole number like shoe size that we talked about, or the median card that we played with the cards yesterday, okay? Now we're talking P's in this chapter, and you have a lot of P's in your formulas, and we are going to do a couple examples together tomorrow. Thank you guys for watching. I love you so much. I'll see you later.